Welcome everybody to today's CSIA webinar. Control System Integrators are critical to Industry 4.0 connectivity. My name is Colin Hammond and I will be your host today. For those of you who are unfamiliar with CSIA, we are a global nonprofit professional association with over 500 member companies in 40 countries. Our mission is to advance the practice of control system integration to benefit our members and their clients. Our vision is to ensure that manufacturing and process industries everywhere have access to low-risk, safe, and successful application of automation technology. CSIA membership offers members access to resources needed to attain and exceed business goals. To highlight just a few of our many member benefits, the CSIA Best Practices Manual guides control system integration companies in the setup and running of a solid company. CSIA Business Insurance Program offers members an excellent insurance program for business owners, subcontractors, and more. The program includes members from all over the world enjoying the peace of mind that comes with CSIA insurance. Clients in all industries are now seeking integrators with the CSIA certification alongside ISO. They recognize CSIA certified integrators' commitment to industry standards and business acumen. As a result, being certified can shorten the sales cycle. CSIA Industrial Automation Exchange is the premier automation guide featuring system integrators and suppliers who provide industrial, manufacturing, and process automation solutions. For integrators and suppliers, it's a place to market their expertise. Clients will find white papers, case studies, capabilities, contact information, and engage in conversation directly with CSIA members. Please follow CSIA's online events calendar for all upcoming webinars, including both partner webinars and business webinars. CSIA business webinars feature topics handpicked by CSIA leadership to help you run your business. CSIA's partner webinars are opportunities given to CSIA's industry partners to address hot topics and demonstrate their expertise. You won't want to miss these opportunities to learn from the comfort of your own office or home. And for more information about CSIA, please visit our website or contact us at info@staff.controlsys.org or 847-686-2245. And at this time, I would like to introduce our presenters, Jeff Bates and Terry Hughes. Jeff Bates leads product marketing for ThingWorx portfolio of edge and connectivity applications, including ThingWorx Industrial Connectivity, KEPServer X, and all Kepware products, the ThingWorx Edge Microserver, and the ThingWorx Edge SDKs. Jeff works closely with end users, partners, and industry experts to develop relevant, high-impact messaging on the value of ThingWorx connectivity solutions. Prior to this role, he consulted with leading manufacturers, helping them define growth strategies and tactics. He received his MBA from the Darden School of Business at the University of Virginia. Terry Hughes leads business development for Callisto Integration's IoT practice, including management of Callisto's partnership with PTC. Terry works with manufacturing customers that are undergoing digital transformation to deliver best-of-breed integrated solutions, including PTC's, ThingWorx, and Kepware products. Terry has been in IT and communication for 30 years, and prior to Callisto, he provided manufacturers with digital commerce solutions. He has a BA in Business Administration and a degree in Electronics and Communications Engineering. And with that, I will now turn it over to our distinguished presenters. Welcome, Jeff and Terry.
Great. Thanks very much, Colin. So
yeah, thanks, Colin.
We want to start out with a brief discussion around the challenges that are inherent to Industry 4.0. And then we can go into explaining how control system integrators are critical to solving those challenges. And there are a number of challenges associated with Industry 4.0. A lot of the stats that we've seen suggest that really only about a third of Industry 4.0 or IIoT or smart factory projects are successful at scale or successfully make it past the pilot stage. And, there is some indication that those stats are improving, but really suffice to say that to date there have been more failures than successes. And there are a number of reasons for that, but certainly a big part of it has to do with these two groups that we have listed here and that you certainly hear a lot about, IT and OT. And, some of the things you hear a fair amount about is just how difficult it is to get these two groups to work together, just because they're so different in terms of the goals that they have and the objectives, as well as sort of the underlying philosophies that guide the two groups. But from our perspective, successful Industry 4.0 projects would be a lot easier if it was just about getting IT to see OT's perspective or the other way around. We believe that one of the things that makes Industry 4.0 so challenging is that neither IT nor OT have the answer in terms of how Industry 4.0 should be done. The goals, objectives, and philosophies that are required for Industry 4.0 are different than both the traditional OT space and the traditional IT space. So we'll dive into those challenges and how and those differences. But I just want to briefly touch on why we want to open with this. And so, depending on where you fall, if you are a control system integrator who's interested in Industry 4.0 and helping manufacturers transform their business, then this intro into Industry 4.0 will give a sense of the challenges and attitudes that you're likely to run up against. If you're a control system integrator who's already offering Industry 4.0 services, hopefully you've seen some of these dynamics, and hopefully some of this messaging is messaging that you can use in future projects. And if you're an end user in either the IT or OT space, and you're thinking about kicking off an Industry 4.0 project, or you've already kicked one off, then hopefully this discussion of challenges and differences will give you a sense of some of the hurdles that you'll run up against, and you can really learn from the mistakes of others instead of needing to learn the hard way. So we'll dive into some of the differences between Industry 4.0 and traditional projects. But Terry, before we dive in, anything you wanted to add to that?
Yeah, thanks, Jeff. So my role on the call today is as follows. We're a systems integrator. We are a control systems integrator. So my job today is to share some insight. We've been doing this for 30 years. So we've been doing digital transformation long before it was called that. And we've had hundreds of projects working with both IT and OT, probably before they were called that too. And we've learned a lot along the way. So my job is to share some nuggets and some insights from some real examples along the way and give you some guidance as to what would make a good approach and a good and successful, whether it's a digital transformation project or just a plant level controls enhancement. There are good ways of doing it and there are bad ways. So I'll share some of that with you today.
Perfect. Great. So we'll dive in here, and to get started, let's compare Industry 4.0 to traditional OT applications. And I think we have been connecting as an industry. We have been connecting and getting data and using data from production assets for a very long time. So on the one hand, there have been these types of projects going on for a long time, but fundamentally, we believe that Industry 4.0 or digital transformation is different, and this is kind of our perspective on how it's different. So if you look at traditional OT applications, you can see we've been collecting data, using it to improve production for quite some time. In a lot of these different systems, MES, SCADA, Historian. So we've been doing validation, real-time monitoring, visualization, and time series storage for quite some time. But we haven't. What we really haven't had as an industry is the combination of that data. and a combination of those functions. And so just to give one example, if you wanted to visualize data over time, that's easy to visualize data with a SCADA system in real time, but visualizing data over time, that's a little bit more difficult to do since most SCADA software traditionally only offers that real-time visualization. And there are certainly tools out there to do it, but really the Industry 4.0 is moving us towards being able to do that type of thing. So that's just one example. I think another key example is, what if you wanted to do one-off analysis that wasn't directly built into one of these platforms? Or if you wanted to, take action based off of some automated analysis that you have. Well, what we've seen in most cases is that in that case, you're going to export the data to Excel. Lots of people joke that Excel has the highest market share in terms of manufacturing operations management software, which in some cases is probably very true. And so that is the way we've been doing things. It's certainly one way to do things, but it presents some serious challenges in terms of, if you want to get data from more than one of these systems into Excel, there's probably a lot of data cleaning and kind of reformatting that you'll need to do to get everything into the same format. And then also, at a very small scale, you can get the insights using Excel. It's a very powerful tool, but it really doesn't scale across an entire enterprise. What we have today, in a lot of cases, or what we've seen, is that we've created really an army of analysts that are creating really useful insights, but then they're trapped within an Excel document at a specific site and can't be easily leveraged by the rest of the organization. So some of those challenges are what we're trying to address with Industry 4.0. And I think it's important to note we're not replacing any of the existing functions of those traditional systems, since they all have their own purpose and function. But what we're doing is really enabling those insights that are typically generated locally to be shared across the entire enterprise. And that is done most easily with an IoT platform or something similar. And it's important to note, I've got the cloud listed here, but these IoT platforms don't necessarily have to be in the cloud, but there's certainly huge benefits to using public IoT cloud infrastructure, and it really helps you ensure that you can utilize insights across multiple facilities across the entire enterprise. And really, the beauty of an IoT platform is that it's allowing all the data from different systems to be used together, regardless of the system where it comes from. It allows for analysis. It allows for orchestration, automated actions, and that's all oftentimes occurring at a single centralized location and pane of glass. So that's our perspective around how Industry 4.0, or some of the ways that Industry 4.0 is different than OT applications. Terry, I don't know if you want to mention sort of how you've seen this borne out in practice at all.
Yeah, if you look at the left-hand side, there is data generated, right? But it's functional. It's data that is there just to execute the task in hand down at that level. Data isn't generally created on the left for any other reason. There's no need to. Data is typically not extracted or shared any further. But if you look at the right-hand side, Industry 4.0, one of the most powerful parts of it is extracting the data, normalizing it, and pulling it up a few layers so that the business, the enterprise, can get business-wide analysis and visibility. So it's data for different uses. But Industry 4.0 is an approach, which we'll talk about a lot in this webinar, that simplifies and normalizes the data down at the lower levels for the things that you've got there in that box: visualization, orchestration, and analysis, things like that.
Great. And this is on the right hand side here with those things. Often the things that are listed in that box, oftentimes that is more similar to a traditional enterprise IT project, where you're trying to bring analysis into that single pane of glass. But again, those enterprise IT applications are different than Industry 4.0 applications, in part because all of the data in a traditional, or most of it, all of the data in a traditional enterprise IT application is coming from the IT side of the house, or it's more traditionally coming from the IT side of the house, where it's being pulled in from a ERP system or a CRM system or a database of some sort. And with IT enterprise projects, there are very well-established ways of getting data out of those systems. Most of them have fairly well-established APIs or protocols, and they make the data available, not only available, but available in a format that is useful. Most traditional enterprise IT systems are not pulling data from the OT or operations network, which is in most enterprises kept separate from the IT network. And that's really the major change with Industry 4.0. It's with Industry 4.0, it becomes necessary to bridge the gap to reach down into the OT network and pull some of that production data. And with devices and systems in the OT network, it's usually the complete opposite of those, very well-established APIs and protocols. The systems and devices at that level are not built to transmit data easily, and when they are, it's usually not in a format that is immediately usable. It would require a lot of cleaning. And this in itself, I'm not saying it is an insurmountable challenge. The data is not completely inaccessible. There are protocols to transfer data. There are systems, ways to get data out of the systems on the OT network. But really what we've seen as the bigger problem is that a lot of times the groups that are responsible for deploying Industry 4.0 projects assume that data collection process is going to be similar to what it looks like in enterprise IT. And because of this, oftentimes they'll leave the data collection step until the end of the project, or we'll just make poor assumptions about how much effort that data collection is actually going to take, and that leads to ROI estimates that potentially don't work out. And that is really a lot of times where we've seen Industry 4.0 projects fail. So we want to take a little bit of a deep dive here. If we can kind of say it's difficult all day to get data from the OT side of the house, but we want to give a little bit more of a specific view of how it's different. And again, if this will probably be familiar if you're a control system integrator, but again, hopefully you can use some of this messaging as you begin to work on Industry 4.0 projects, or to help your customers understand the challenges that they'll face. Terry, before we dive into OT connectivity specifically, or Industry 4.0 connectivity specifically, anything you wanted to mention about the IT side of the house?
Yeah, so what we've seen, typically a plant, let's take a particular plant. It's built up over many years. There might be 20 or so of these systems, bottom right there. And they're all disparate, they're all different, but that's fine, right? The plant runs. People have the knowledge, tribal knowledge a lot of the time, of those 20 different systems. But you're right, when it comes time to break out of the four walls of the factory, and if you think of the red line there as the four walls of the factory, you have to break out of those four walls and bring data up to the IT layer to achieve Industry 4.0. You have a big problem. You have 20 different protocols, and all of a sudden this new word cybersecurity appears. If you're bringing 20 different connections and 20 different protocols through that wall, if you like, how do you do that in a secure way? And you're right, that's where a lot of the projects they stumble at the very least, because connecting all these strange protocols into a very normalized IT world is a challenge for both sides. So the more you can standardize the bottom right before you break through the walls of the factory, the better.
Yeah, and good point. I neglected to mention on this chart here, the graphic is obviously just is an example of the type of thing that you might see on an OT network, and certainly not fully representative of the complexity of some of those networks and systems. So let's dive in and talk about how IT data, or the type of data that enterprise projects have typically relied on in the past, to Industry 4.0 data, or OT data. And there's a couple of axes we want to look at this, and the first one is the state of the data. IT data is often stored in a database. Most likely it's a SQL database or something along those lines, where you're storing, customer transactions, employee data, or something along those lines. And so, the first difference is you need to contrast that to OT data, where the data that's coming off of a PLC is real time, or the data in a SCADA system is all real time. And if you're not somehow capturing that, it's gone forever. On the other hand, you can't capture all the data and just drop it into a SQL base, or even a time series database, because some of that data is changing every 100 milliseconds. Your data storage bill would be astronomical if you just said, hey, we're going to store everything. So you need to store a lot of the data, but you need to be very smart about the data that you need and how it rolls up into the critical KPIs and when to be storing that data. So the next axis is context. And fundamentally, IT data, I don't think it's too far to say that IT data has metadata associated with it. If you think about a typical SQL database, you have a huge number of columns, so that every row, every data point, has a significant amount of data associated with it that you can query. For just to give an example, the transaction might have an amount associated with a dollar amount, a timestamp, an account, an address of that account. All that data is associated with one data point. With OT data, that's very different. You are maybe lucky to get a timestamp and a value with no additional context. And I will mention that that's not universally true. There are lots of people working on getting metadata and a structure associated with the data, but you may not even, in a lot of cases, and especially with legacy machines, you may not even get a data type for a piece of data without talking to a controls engineer. And just to make that real, I think the best example is always the Modbus protocol, which is pretty ubiquitous, used everywhere, present in most facilities. And with Modbus, you have to know the data type going into, and this is getting a little bit low level, but you have to know the data type going in to read the correct registers. And we haven't even started to talk about the context of what that data is, in terms of, this piece of data represents whether or not this machine is on or off. That machine is part of this line, which is making this part, which is part of this product. That's all stuff that's needed for Industry 4.0, but not immediately present on the device. And again, there's work being done to get closer to that, but for the most part, you're just going to get raw data in a timestamp off of the controller. Lastly, I want to briefly touch on data model. And again, I think Modbus is a good example of this. Again, since it's ubiquitous and very representative of a lot of legacy devices. And so, in terms of data model, kind of what I'm talking about, or an example of this is, again, you need to know that registers 40,000 to 40,003 have been configured to hold a variable that is in the long data type. Because if you just read register 40,000 as a word, it's not going to mean anything. And of course, this is all speaking specifically if you're talking directly to a Modbus device without the benefit of any sort of abstraction layer. And I will say, if all this talk of data types and registers and that type of thing has gotten your eyes to start to glaze over, then and you might be starting to regret joining a webinar that's talking about stuff at such a low level, you really want to keep listening to this, because this is the exact type of thing that you don't want to have to learn when you're going forward with your Industry 4.0 project. You really want to be able to work with some sort of tool that is going to provide a layer of abstraction, and ideally a control system integrator who will have a very good understanding, as Terry said, of the tools and the methods to provide that layer of abstraction. And I think just before we move away from this slide, I think one analogy that might resonate if folks on the call have a an IT background, is the difference between machine code and some abstracted language like Java or C#. OT data without a layer of abstraction is very similar to machine code, where you're talking about the registers, you're talking about moving data from register to register and moving the pointer from one register to another. That's a lot of, within Kepware, that's a lot of what our developers are trying to abstract away. With that tool that provides a layer of abstraction, you're at least getting closer to an abstracted language where you have a name for a data point. It's in a format that you can work with. So, hopefully this is an analogy you can use to highlight how seriously the data collection phase for Industry 4.0 needs to be taken. I think most IT people that are in their right mind would never choose to write machine code voluntarily. But unfortunately, lots of folks who are in the IT space and looking at deploying Industry 4.0 seem to be willing to sign up to interface with a Modbus device or other legacy OT devices, grabbing a Modbus SDK off of a free site or something like that. And that fundamentally comes down to a very similar choice, where if you're not interested in writing machine code, you are probably also not interested in working directly with these legacy OT devices. So I know we spent a lot of time here. Before we move to the next one, it gets even more complicated than this. We're just talking about the data itself. We haven't even gotten into networking or security. But I hope the takeaway from this slide is that doing this all internally without tools and that would provide a layer of abstraction, or people who are very deeply understand these challenges, is very, very difficult. Terry, anything you want to add to that?
Yeah, as a systems integrator at Callisto here, we analyze what good IT data looks like. So there's good and bad, and there are 4 words all finishing with a D. And I'll go through them. I'm not going to explain them. They're all fairly obvious, and I think you've explained them very well already. The first one is abstracted. Good IT data is abstracted. The second one is normalized. The third one is centralized. And the fourth is contextualized. And you'll hear those themes throughout this presentation. But look at IT data through that lens. Is it abstracted enough from the OT layer? Is it normalized so that it can be used in a common manner? Is it centralized so that it's all in one place rather than the plant level? And is it contextualized so that when one data set matches another, some analysis and visibility can be pulled at the enterprise level? So those 4 words are really key to look at that IT data model.
Perfect. And that's a great segue to the next slide, where, if you come from a control system integrator background, or you come from the OT background, you may have a very good sense of this, and you may be saying to yourself, oh, great, I understand all of that. I understand registers. I understand how controllers transmit data. So I'm ready to go for Industry 4.0. But I think it's important to note that Industry 4.0, again, is different from the way that we've traditionally done things on the control system side or the OT side. And I think there are exceptions to this. There are examples where data has been abstracted and follows the 4 tenets that Terry just mentioned. But in a lot of cases, we see a traditional OT project not following those best practices. And it's possible to get away with that for, if you're doing a SCADA implementation, or, a plant, some sort of visualization for a specific line, but can't get away with those things in Industry 4.0, as Terry mentioned. And so we'll go through a couple of examples here. In those projects, in the OT projects, oftentimes the feeling is that really the most important thing is just to get things connected. So it doesn't really matter if you're using a driver that's built into the SCADA system, or a third-party driver, or if you build the driver on your own. Any of those things are going to provide connectivity to the devices, so they'll all work. that, again, unfortunately, that philosophy does not work in Industry 4.0. Even if every machine or line, if every single thing that you're trying to connect is a one-off science project like that, then it's just not going to scale. And that's where things a lot of times get hung up. So just as an example, maybe you roll out your Industry 4.0 solution to a number of CNC machines of one type, but then another line or another factory has a CNC machine of a different brand, and the connectivity that you used for that original brand of CNC machine isn't going to work. And if you start from scratch every time that you need to connect a new machine or a new brand of machine, it's just going to take the time that it takes to get connected is going to vary significantly, and your ROI for each project is really just going to be all over the place. It's similar to an enterprise IT project where the connectivity has to be standardized and repeatable, has to work across all machines, devices, and sensors that you want to connect. So that's around standardization. The DIY feasibility part is very similar story. If you're thinking about connecting to a single type of machine, it may make sense to quickly just build a driver to get basic connectivity. But when you move to Industry 4.0, there are a number of problems with that. And one of those is that the requirements with Industry 4.0, the requirements of the system may change as you get new insights. You may be looking for different kinds of data. You may be looking to do different things with your data. So if you built that driver in-house, you may not have built the right features into that driver. And with the changing requirements, you'll have to go back and upgrade it. And we're talking about an enterprise-wide deployment here. So if you start, if you're talking more than 5 or 10 in-house drivers, you really can't afford to have a full team go back and update those every single time a change needs to be made. With Industry 4.0, you're really looking to get to that flexibility that would be very much hampered with that type of a setup. And then just lastly, Terry mentioned before, but there's the issue of security. With an HMI, or a local system, that data is just being passed within a relatively small and hopefully very well protected network segment. So security for those types of projects hasn't been a giant concern in the past, or at least that's what we've seen with some legacy projects. But as Terry mentioned, with Industry 4.0, you're passing that data at least into the IT network, if not, into a cloud. So security is absolutely critical. This is the special sauce of your company. This is how you make what you make, and how you make it better. And so, just to give one example on the security side, one important part of security is constantly maintaining and updating software. Or security within software is an arms race, and both sides are sprinting just to keep up. So that means that if any software that hasn't been updated in 2 years, you pick your number, 2 or 3 years, that software is inherently insecure. So this requires a new practice where connectivity software needs to be maintained and updated on a regular basis. And if you're doing it, connectivity on your own with built-in, in-house drivers, that again, it scales to a level of complexity that is unsustainable. So, Terry, any experiences from the field that you'd want to highlight here?
One of the themes that we'll develop in the second half of this webinar is rapid scaling, because when a company, manufacturer, let's say, wants to adopt Industry 4.0, one of the only benefits you get is when you rapidly scale it across the whole business. If you only do it in one plant, it's hardly Industry 4.0. And so before rapidly scaling, you need to figure this stuff out. You need to have a comms network that's standardized and secure, as you said, so that when you are ready to roll it out, you're not there in the weeds trying to figure out all those connectivity options. So I think that we'll develop that as we go through the next part.
Great. Yeah, and I think so. That was hopefully a useful primer on kind of how this is different than some of the projects that you've been involved in before, and hopefully enables you to go into some of these projects with eyes wide open. I will, before we move on, I will mention that this list of challenges is certainly not exhaustive. These are just some of the ones that we wanted to highlight. And, we have spent a lot of time on challenges here, but companies who have done this successfully have seen amazing and transformative value. We'll talk a little bit further on about some of the value that companies have seen, but we won't touch on sort of the value of IoT and Industry 4.0 overall. There's a lot of material out there on that, but I think it bears mentioning that if you can do this correctly, if you can do it right in a way that rapidly scales, it is hugely valuable and transformative for the company. So let's turn to a couple of frameworks and thoughts about how we've seen those companies who have been really successful with this, how those types of companies have gotten started.
So first of all, let's acknowledge that this is a McKinsey diagram from a McKinsey article, and I want to make sure you have access to that article because it's really good. It's an article called "The Next Horizon for Industrial Manufacturing: Adopting Disruptive Digital Technologies in Making and Delivering." If you can't find it, just ping me at Callisto. It's Terry Hughes. I can send you a link to the article. It's public domain, but it's a really good model. And I sat down today before this webinar and I read it again. And before this diagram, the article talks about the 3 ways that a company can unlock the value of Industry 4.0. And it lists them. And it's very interesting, almost coincidental, that it says connectivity, intelligence, and flexible automation. They're the 3 building blocks. And you've heard those themes earlier. And then it moves on to talk about the keys to success here. When we at Callisto look at a successful project, it's a 3-legged stool, and the 3 legs are the people, processes, and technology, probably in that order. And so a lot of what you see on this slide is talking about the people. But this slide does embrace all 3. The left-hand side is to strategize the process. And we'll talk about it on the next slide too. You have to analyze the processes that you have and how to reinvent them, frankly. The middle one talks about the infrastructure, technology, and of course it mentions a partner ecosystem. Technology is so widespread these days that trying to do it alone or figuring out how to implement on your own is just not practical anymore, which is why companies like ours are there to help manufacturers to figure out best of breed, how it all hangs together, etc. And then on the right-hand side, it's all about the people, isn't it? Mobilizing the organization, bringing IT and OT together, which we'll talk more about later in this webinar, and to have a transformation and a transformative plan for the whole organization. And when we look at it, we come down to 3 things: technology, training, and transforming. I know the lists always have 3 of the same letter. Well, this is 3 T's. It is partly about the technology. It's about empowering and training the people. And then it's about transforming the organization. So as we move on to the next slide, which is the another acknowledgement's coming. This is LNS Research. Joe Perino published this in a digital twins paper. Again, if you can't find it, it might be harder to find. Just ping me at Callisto. This is what he calls the Industrial Transformation Framework, and we really think it's a powerful model. There are 2 axes. If you look at the top down, which you can see on the right, you've got the various roles and functions of stakeholders in the organization, and they're all different, so you need to understand their motivations, their needs. And if you look left to right, you've got the process that we typically take our customers through, starting on the left with defining the business objectives. And what we say is, how does your business need to change? Because your competition is changing, your competitors are out there, they're reinventing, there are always upstarts, even in manufacturing. How do you need to adapt and change? Things like mass customization, that's a big theme. Build to order, not build to stock. Just-in-time delivery, those kind of things. So we get them to think at the very highest level on the left there. The second one across is the strategic initiatives. Pick a few battles, pick a few areas that are ripe for reinvention and innovation, and then assess very quickly how the people, the process, and the technology needs to change and can it change? Because there are areas of the business where you may conclude it can't at this point, and then create a plan. In the middle, you've got the architecture discussion, which comes straight after the first two. So before you dive into technology, you've got to figure out a future-proofed architecture throughout the ISA 95 stack, if you're familiar with that, from the controls layer all the way up to ERP. Without a good architecture that's business-wide, you can't move to the fourth one, which is the solution selection. Then it's a case of looking at vendors, doing RFPs, doing pilots. We'll talk about that later. Identifying a few close-knit teams that can actually run with it. And most importantly, defining the outcomes and the success criteria. When you're looking at putting in a solution, what does that look like? How will you measure success? And finally, on the right there, the fifth one, it's all about implementing and managing the change. And what we do there is a capability maturity model assessment. So we look at where each plant is and each layer. So if you look at the layers on the right there from the sea level down, what is the maturity, their ability to adapt and accept the change? And we work on, okay, that's where you are today. This is where you need to be. How do we get there? So that's we really like LNS's model there, and it's a great way of taking a customer through that journey, and in phases and by layer too, from the sea level all the way down to the IT and OT leaders. Back over to you, Jeff.
Great. So really good frameworks for getting started and for getting started in a way that will lead to future success. I wanted to briefly touch on the connectivity and the initial approach around connectivity. And what we've seen is that there are really two approaches that we've seen manufacturers be successful with. And the first on the left here is really to focus on upgrading the linkages between IT and OT so that data is ready to be consumed in an abstracted way with all of the necessary content. This is focusing on making sure all the data within your operation is adheres to the 4 Ds that Terry was talking about earlier, so that you can get to the rapid scaling. Once you are choosing those solutions, once you are choosing the analyses and problems that you want to go after, all of the data is available to your engineers so they can start analyzing it for insights. So that's one approach that we've seen folks be successful with. The only downside of that is that as long as you're just focused on upgrading the infrastructure, you're not focused on the insights and making improvements. So it delays a little bit the return on the project. But again, as I've said, we've seen a ton of companies be very successful with this approach, and as soon as the infrastructure is in good shape, they hit the ground running with analyses and insights, and the scaling is it's amazing how quickly they can scale. The second way that we've seen manufacturers be successful is with a scalable pilot approach. And I think it's very important to note that a scalable pilot is very different than just a pilot. With a simple pilot, you run the risk of doing exactly what Terry mentioned earlier, which is making a project in a specific location that doesn't scale. As he said, that's not really Industry 4.0. So if you do your pilot without consideration for how other machines, how other lines, or how other factories might be different, that's where you run into this idea of pilot purgatory. So the solution is a scalable pilot where you're making a pilot, you're focusing that pilot on demonstrating real value for a specific machine or line or factory, but it's designed with scalability in mind so that it's taking into account other types of machines, other architecture, other parts of the organization that are going to need to benefit from the same level of connectivity and analysis. So what you end up with is a architecture that is repeatable, standardized and repeatable across the entire enterprise. And as I've mentioned, we've seen companies be successful with both methods, but it really requires being very deliberate around which method they're using, and not just jumping into a pilot that is not going to be scalable or repeatable. So at this point, we've talked about some of the key challenges and some of the ways that successful companies got started. And I just want to highlight, or sort of put a fine point on where control system integrators fit in. And there is, and from my mind, I can't talk enough about this. There is significant value that control system integrators can add at every step of the way. The chart that we have here is really just a smattering of the different steps of the process that system integrators can at least facilitate, if not completely deliver. And especially when it comes to connectivity for Industry 4.0, control system integrators are in such a unique position where they span both the OT and the IT worlds. They have, as Terry mentioned, they've done this a lot. So they don't have any illusions about how difficult the process is going to be. And really, once the goals of the project are set, they can help architect and implement, or they can actually take over the architecting and implementing that is going to be most successful. And it doesn't, it's not just on the software or IT side, it's with regards to both hardware and software and networking. So I think, I can talk about this ad nauseum, but it's really important to mention that we work with a ton of companies that have successfully implemented Industry 4.0 or smart factory projects, and many, if not the majority of those companies have partnered with a control system integrator for at least a portion of the project. So, just from my personal perspective, I look at a fact that only a third of Industry 4.0 projects have been able to scale. And I look at, I have a cursory understanding of some of the reasons that they don't scale, and especially when it's with respect to connectivity. And then on the other side of that, I think about all of the incredible projects that I've been involved in where system integrators have delivered so much value. I can't help but think that there's so much value in pairing system integrators with end users who are doing Industry 4.0, and I can't point to why control system integrators aren't more involved in some of these projects, but I do have the strong belief that that control system integrators can push some of these projects, a lot of these projects, from the pilot purgatory that many of them are now to a really highly successful project. And we wanted to give you a couple of examples of just how well that pairing can work. So I'll pass it back over to Terry to highlight some success stories.
Yeah, thanks, Jeff. Just on the slide that you've got here, Callisto's been around for 30 years, and we still have some people that have been with us for almost the entire length of the company's existence. And I asked them, I said, okay, so if you look at the most successful projects, what are the factors that you can point to? And I got 4 out of them. The ones where we've been successful are when we went in early. So if you look at the chart, we got in really early, and we were able to work from a very early position with the customer. We worked with both IT and OT. We bridged that gap. That's number 2. The third is we acted as a facilitator, and you got the word perfectly there on the slide. Not a consultant, but a facilitator. And when we say facilitator, that's really facilitating all of the various parts of the company and bridging that gap, IT to OT. And the fourth is when the customers leveraged us as an independent set of eyes. Because vendors say what vendors want to say because they've got a product to sell. We have an independent view. So those are the 4 factors. Get in early, work with IT and OT, act as a facilitator, and become an independent, trusted set of eyes. So I've got a couple of quick case studies. This is a consumer packaged goods manufacturer. And we've talked about this, that historically the OT stuff never had to break out of the 4 walls to anything else. But 2 things changed. Management started demanding visibility into OEE, and that's common. We see that a lot these days. And They had a particular new machine builder that provided them with hardware, equipment, and that contract, and we're seeing more of this, stipulated that the performance data had to be sent outside to the manufacturer of the machines in real time. What we found interesting is when we sat down and analyzed the needs, they're very different. Look at these. The OT team said, well, it needs to be easy to connect, minimal disruption, easy to maintain, and we don't want to spend much money on it. We've already spent enough. And IT said, well, it's all about cybersecurity. We need to figure out whether we do this at the plant level or in the cloud. And if we're going to do this at all, we should probably get uniformity across the business. So we worked with both sides, and we implemented one system that achieves three things. The VP of Operations now gets the data he needs to run the plant. The CIO can deliver all sorts of slice and dice visibility and analytics to the leadership around things that they could never see before without walking around the shop floor looking at whiteboards. And the machine builder can remotely monitor the equipment. So that's an example of where needs change, and you have to have a system-wide approach to address the various needs of the different, what were silos in the business. Another good example is a discrete goods manufacturer. The good news is they had or have a vision for Industry 4.0. They've got the vision, but the challenge is, as you can see there, all their plants are different. So they want to be able to right-size the investment into each plant. They make different things. They're at different stages of maturity, as I talked about earlier. And the good news is they want to invest in a common enterprise-wide approach. So we worked with them in 5 ways. Requirements gathering of each stakeholder. If you remember the diagram, C-level people all the way down. What are their needs? They're different. We did site assessments of each plant to see whether they were physically ready, infrastructure-wise, communications-wise, connectivity, and also meet some of the people that have to adopt this technology. Number 3, we looked at whether we could standardize the control systems and the connectivity where possible, which would make it easier. That was one of the themes we talked about earlier. Get ahead of that, get that done before you have to do the big Industry 4.0 implementation. Then, only then, look at a platform approach, as we've talked about. And finally, make sure we architect it based on standards, because then each plant can slot in as their maturity dictates, as their needs dictate. They can slot into a standards-based approach to a platform. They can take the pieces of the Industry 4.0 initiative that they need when they need them, add on when they need them, and that really is the most cost-effective way to achieve Industry 4.0. So those 2 case studies there nicely pull together a lot of the themes we've talked about. Over to you, Jeff.
Great. So I want to make sure we have a couple minutes for questions. So just briefly on next steps. Next steps are going to depend on A, what your role is, as well as B, kind of where you are in the process here and how far along the Industry 4.0 journey is. And so there are certainly a number a number of next steps. I think the slides that Terry showed around the frameworks for getting started have a lot of insight there, and as we've responded to some folks, the slides will be passed around after the webcast. But really, I think an important next step, regardless of where you sit in the value chain here, is understanding that control system integrators can add value to this. So one of the things we've seen is, in a lot of cases, it's the IT organization who's really taking the lead on these projects. Really, it would encourage folks to understand the value proposition of a CSI. Hopefully, we've been able to highlight that today. If you're more of an OT leader and you're probably a little bit more familiar with control system integrators and the value that they offer, make sure that if you are an OT, if you are a leader in Industry 4.0 project, make sure you're advocating for the appropriate use of and deployment of control system integrators, or you're working to get control system integrators hooked up with the right people in leadership roles on the Industry 4.0 project. And if you're a control system integrator, then we'd encourage you to tell this story and explain to end users how useful and how valuable you and your organization and the industry can be to Industry 4.0. So I'll quickly pass it back over to Terry, and then we'll do as many questions as we can.
Yeah. Again, I'm here to bring some final context. And when we talk to our customers, and if you are a control systems integrator like us, and this will resonate, right? So when we talk to our customers, we say, look, you've paid us a lot of money. By the way, we bill for our services, but where we've been successful, the customer says what we do always pays back handsomely in the following areas: lower risk, and there's a lot of risk these days with all the new technologies out there. Better use of resources and capital, lower total cost of ownership, and the most important that our customers tell us is using a systems integrator is the fastest route to improving the bottom line. That's a quote. The fastest route to improving the bottom line, which is what it's all about. So those manufacturers that try and go it alone, yeah, not Industry 4.0. You need help from not only the technology vendors, but people like us and the CSIA members. So that's really the key message: the fastest route to improving the bottom line in Industry 4.0.
All right, thanks, guys. So we have time for one question. In an ideal world, would you say that IT doesn't have knowledge of the manufacturing environment and OT shouldn't be concerned itself with IT?
Yeah, so I think the question was, in an ideal world, would IT focus on IT and OT focus on OT? Terry, really interested to hear your perspective on this, but from my perspective, I think some of the successful, or at least a handful of the successful companies that we've worked with have really merged those two groups, or at least had kind of a reckoning that IT isn't just about, laptops and service desk. It should be applying the best practices of IT also to the communication and computing systems in a factory. So without going too far into detail, I think there's a growing realization that is the case, and I think I've seen that in a couple of specific instances pay huge dividends for companies.
Yeah, they can't work in isolation any longer. The manufacturers that think they can won't change enough to fight off the competition I talked about earlier. They have to embrace each other. They have to work together. And the key thing, if you're a systems integrator, is to be the facilitator.
All right, thanks, guys. And on behalf of CSIA, I would like to thank Terry and Jeff for this informative discussion. I'd also like to thank all those attending. We hope you found the webinar informational. When you close out of the webinar, a link will pop up for a brief eval. We would appreciate if you would take a moment to share your feedback with us. And we'd also like to remind you that a recording of this webinar will be available for viewing within 30 days of this event. Please visit the CSIA website to view this recording or a past webinar you may have missed. And that concludes our program for today. Once again, thank you for joining us, and have a good day. Thanks, Terry. Thanks, Jeff.
Thank you.
Thank you.